Okay, welcome back. Today we are going to tackle question 6 from 2023, May-June of A-level maths. Well, this is paper 1, so it's AS level maths. So question 6 says, the diagram shows a sector OAB of a circle with center 0. Angle AOB equals theta radians and OP equals AP, which equals x. Show that the arc length AB is 2x theta cosine of theta. Okay, so we are given a sector with a triangle inscribed inside of it. This triangle is isosceles, as we can tell from the x's. Now, one property of isosceles triangles is that the base angles are the same, and so are their sides over here. Now, we want to find OA, because using the radius we can get the arc length, because the arc length is just theta times the radius. So how do we find OA? Well, we can find half of OA by splitting this triangle, this isosceles triangle, into two right angle triangles. So if we divide it through the center here, we get two right angle triangles. So half the length of OA will be this side over here. Half of OA will equal to the adjacent side of this right angle triangle we have over here. Now, how do we find that adjacent side? Well, we know that cosine is adjacent over hypotenuse, so this will equal to x times the cosine of theta. Very simple. And that's going to equal to half of OA. So half of OA is equal to x times the cosine of theta. Now we're concerned with OA, the full length of OA. So we need to say OA, multiply both sides by 2, equals 2 times x times the cosine of theta. And then we can just multiply this by theta to get the arc length, but for the sake of completeness, the arc length of AB will equal to theta over 2 pi, because there's 2 pi radians in a circle, in a full circle angle. Multiply this by the circumference formula, which is 2 pi r, and r in this case is the line OA, and this will just be theta times OA, because the 2 pi's cancel out, and that's how you get the radian formula for the arc length. So this will be theta times 2x times the cosine of theta, and we can just rewrite this as 2x times theta times the cosine of theta. That's part A done. Now let's look at part B. Find the area of the shaded region APB in terms of x and theta. Okay, so we want to find this region. This is just simply the sector minus the triangle. I could have made this a bit more curved. So the sector minus the triangle. Now the area of the triangle is just the area of these two smaller triangles multiplied by 2. So we can say 2 times a half times the base times the height. So the base over here, let's say it's x times cosine of theta. It'll be x times cosine of theta times the perpendicular height, which is going to be the sine of theta times x. So x times the sine of theta, because it's opposite over hypotenuse. Now as we can see here, it's half base times height, and we have times 2 here because it's two triangles, so we're effectively just going to cancel out these two, and we're just left with the area of, let's say, AOP, the area of triangle AOP is x times the cosine of theta times x times the sine of theta, which is going to be x squared times the cosine of theta times the sine of theta. Then we can solve for the sector AOB. Sector AOB will equal to, so theta over 2 pi radians in a circle times the area of a circle formula, which is pi r squared. In this case, the radius is OA, so OA squared. Now these pi's will cancel out, and we just get theta over 2 times OA squared. So this will equal to theta over 2 times 2x times the cosine of theta squared. Don't forget the square, it's very important, because when we square this, we get 4x squared times the cosine squared of theta, or cosine of theta, and we can put the squared outside for clarity. And the 2 over here will cancel out with the 4 over here, so we get 2 times theta times x squared times cosine of theta squared. So we just need to subtract these two equations now, or expressions, and we get 2 times the theta times x squared times the cosine of theta squared minus x squared times the cosine of theta times the sine of theta will equal to the shaded region APB. You can say APB. Now we can take a common factor here. See that x squared here is common in both of them, and you can say 1 cosine of theta is also common. This has a squared, this has a 1 over here. So this has a 1 to the power of 1 there. So I'm just going to take the x squared outside. I'm going to take the cosine of theta outside, and we're left with 2 theta times the cosine of theta, because that's a squared, minus the sine of theta. And this is as far as we need to go. We don't need to simplify any of this. So that's how you get full marks on this question. Thank you for watching, and please subscribe.